Okay, welcome to another episode of the Vehicle Network podcast. The Vehicle Network is a resource and networking platform held within an application that's available with both Google and iOS app stores. And we aim to give you some insights into automotive investigation and information that can assist you in your investigations. And the Vehicle Network podcast is now on episode 7, and I am delighted to welcome to this episode Dr. Ken Tindell from CANBus Automotive Labs. And we're going to talk about all things CANBus and securing CAN, and just have a little look back at where we've been in the past and where we may be going in the future. Ken is a very experienced practitioner in this field, and I'm looking forward to getting his take on some of the things that I'm curious about with regards to CAN and how it impacts on some of our investigations. So welcome to the Vehicle Network podcast, Ken.
Nice to be here. Thanks.
Could you just give us an introduction to yourself, your background, and where you have been and where you are now?
Yep. So I first got into automotive in 1993, I think it was. I was doing my PhD in real-time systems analysis, and it turned out CANBus was perfectly suited for this as a case study. And then after I presented it, some guys from Volvo got in touch and said that they wanted to use all this timing analysis to predict and guarantee all the performance of their CANBus in the new vehicle. And they gave me a contract and said, go and form a company and build all the necessary stuff to get this all working in their new car platform. So I've been in the car industry ever since.
Yeah.
And then so I founded a company, and we did lots of stuff on real-time systems analysis, and in the end we created a company, a joint venture with Volvo, which in the end got sold to Mentor Graphics, which is now part of Siemens. And all the timing analysis has gone on from there, and lots of car companies use that to analyze their CANBus before they start shipping.
Excellent. And where are you now within the automotive industry?
Yeah, so a few years ago, I started to see that security was an issue inside CANBus, because when we started, the internet was still at that stage dial-up. So the concept of having a car connected to the internet was absurd. So there was no real concept of security on CAN. It's internal to the vehicle. It's like having security on the circuit board inside your PC. It kind of doesn't make any sense.
No.
But then, of course, things move on, and by the about 6-7 years ago, it really started to become you could see it as an issue here. People plugging all sorts of stuff into their cars and connecting them to the internet and things, and then hackers. So we founded CANBus Automotive Labs to look at technology for defending the CANBus from hacks of various types, and that's where we've been ever since. So we've got a whole bunch of technologies we've looked at for that.
Yeah, and are you working with manufacturers at the moment with regards to that?
So we've been in a lot of discussions. In fact, our biggest project at the moment is with the US Army, who want to secure their military ground vehicles from hackers.
Yeah.
There have been some cyber attacks on their vehicles in the past. They've been a bit tight-lipped about exactly what that is, but that is publicly known. So looking to protect ground vehicles, which are using a lot of off-the-shelf automotive parts, because that's how you have to build something. You're not a manufacturer by car industry standards. So yeah, that's particularly interesting.
Yeah, it is, and it's a really valid point with regards to that, because we have got these vehicles that are being used in both military and law enforcement agencies that are susceptible to that. And I think Lisa Knight, if you're familiar with Lisa Knight over in the States, she did some sort of work with NYPD to show what vulnerabilities existed on some of their vehicle fleets as well. And as much as we're looking to secure the infrastructure for vehicles that are out on the road for the public, then these, the organisations of the, the military and law enforcement also need to be mindful of that, because it can have, a massive impact on it.
Yes.
And of course, like you say, the components are, are just used widespread across those different areas. So I can see that is a massive area that does perhaps needs to take precedent over some of the other areas to a degree when we look at national security and global security of our armed forces and law enforcement agencies. So I want to start, if I can, Ken, by just talking about the CANBus, and for you to give me and our listeners an explanation from your point of view as to the basic principles of CAN and how it works.
Okay. Without diagrams and whiteboards and
just
stuff.
we often have to present this to a jury, and I guess it's trying to get that sort of simplistic, shall we say, principle of CAN over. But I would like to hear your explanation of how you would describe that and its main principle.
Okay, so it's probably best to look at why CAN came about, to sort of see and understand why it's the way it is. Back before CANBus, most vehicle systems were connected together with individual wires. So the engine and the gearbox would have a bunch of cables going there, and one would say the gearbox is in this switch, and another one would just open and close switch positions, or maybe voltage levels to indicate speeds and things like that. And as the functions in a vehicle started to go up and up and up, so you've got electric window winders, remote locking, and so on, and more functions come in, the number of cables you need to run around the car just becomes ridiculous. And in the early days, Volvo showed how the car, if it carried on growing at the number of functions over time, the car would be made entirely of copper within a few decades. There was just so much wiring required. So what CANBus does is it's a very simple networking protocol that runs on a twisted pair of wires, and you hook up all the main control units to those pair of wires, and then they all take it in turns to squirt little pieces of information that they would have sent over individual wires. So if you like, it's kind of emulating individual wires. So where there might be a temperature sensor and that's wired into 3 or 4 different control units, now the thing that's got the temperature sensor on it sends a message saying, here is the temperature, and then everything that wants to know the temperature just listens to that little message and picks it up. And it's very different to computer networking like Ethernet and so on that you have around an office, because what CAN is sending around is very, very small piece of information. It's sending them around quite quickly. So you might look at the 4 wheel speeds, for example, of a vehicle, and they might be sent out 100 times a second. So something listening. So for example, if you wanted to work out where the steering wheel was pointing, you obviously could read the steering wheel angle sensor directly, but you could also look at how the 4 wheel speeds have been turning, and then from Ackermann geometry of the steering thing, you can work out whether the car is going straight or curved to the left or curved to the right, because the different wheels will be going at different speeds. So the information is, again, very different to the kind of thing you'll see on a computer network. And the real key property with CAN is, because if you move from all these individual wires and then you're sharing a pair of wires, the main difference now is everyone's got to take their turn. And before, it's very easy because you don't have to worry about that. Now you have to worry about who gets to go first, who gets to go last. Someone comes round and it's their go again. And if you look at, again, the way computer networking does is it just, everyone has a go and they all mush around and then they all have another go and so on Ethernet. In CAN, there's a much more defined way of deciding who gets to send the message first. So the wheel speed one, because that's going, say, 100 times a second, that gets a very high priority. And there's a particular property in the way CAN works that lets things that are urgent with high priority go first, and then things that are less urgent, like very often you send around CANBus things like which country the car is in, because then the radio can tune to different standard frequencies and stuff. And you send that once per second, because it doesn't change the car doesn't change its country very often. So everything's kind of like jumping on and talking on the CANBus, and everything needs to get its thing done in time, and you need to work out where everything goes. So you have a priority that says, where everything who goes first and so on. But that priority is got a double use. It also indicates the contents of the message. So the wheel speeds will have a particular number on one. A particular car company will choose a priority for that, and then everyone uses that priority as an index into it's got wheel speeds, and I can now unpack those wheel speeds and deal with them in my algorithm. So that makes it that's conceptually always caused a lot of trouble with people, because there's two things inside the CAN identifier. One is it's a priority, and one is it's identifying things, and so people get confused by that. So they tend to think identifiers are some sort of address or things, because they think about Ethernet, but it's not like that. CAN is very, very specifically defined for the kind of problems we've got in automotive. And I think this is a bit of a confusion for outsiders when they come along to CAN for the first time, and they think it's like Ethernet, or I think it's like a computer network, and it's very, very different. And the other main property of CAN, which is even more important, arguably, is the way it handles errors. So with Ethernet, if you get an error, bit of electrical noise, some spark plug went off or something like that, and it disturbs the value of a message. With Ethernet, when you get a message and you run a check on the hardware runs a check on the message, and if the check doesn't match the contents of the message, it just throws it away. So that doesn't work in automotive very well, because if you throw it away and you were sending a message that was being used by 4 doors, for example, for locking, and 5 if you've got the tailgate and so on.
Yeah.
You press the button to lock the car. A bit of noise meant that one of them would throw the message away. So then one door would stay unlocked and all the others would lock. And that's just absurd. You can't have that, because otherwise you now need to everyone else and say, oh, I got that message and I didn't get that message. And then it becomes absolute chaos to write the software. And CAN is designed to make this very, very simple software. So the CAN error message system is really, really important. So what it does is, if you get the message, instead of throwing it away, you actually raise by overwriting on the bus, saying I didn't get that, or you write a particular electrical value on the bus, and then everybody else sees that and goes, well, in that case, I didn't get it either, and then the transmitter resends it. So from the software perspective, once that message has been marked off as sent, everybody got it. And that's really, really important for robustness on the way CAN works. Because almost no other networking protocol does that. And lots and lots of the software in the car industry, I think, actually, that people that write this don't know this is actually what's going on in CAN. They don't understand this atomic property, but it's really important. So if you move to something like Ethernet, which doesn't have that, I think all kinds of software will suddenly start breaking in really unusual, strange ways, which will cause all kinds of trouble, because you don't know what's in. So that's a rough indication of CAN. In terms of the physical wiring of it, as I said, it's a twisted pair, and the reason it's a pair of wires is if you've got electrical noise from outside the vehicle and there's a disturbance from the roadside, that will disturb both wires at the same time. So the difference of voltage between the wires will remain unchanged from the external disturbance. So lots of other protocols aren't like that, and then they, if you drive by some very noisy piece of road equipment, or at an airport with radar sweeps or something like that, it causes a lot more trouble on those networks. But CAN was designed for that. It's designed to be very, very cheap, so the wires are very, very thin. They're designed to be bundled in a very small space. They're not supposed, to try and reduce the weight. Everything like that. So it's a very specific to automotive protocol, and it has so many fantastic properties. And I think because it's so old, it was kind of 87, I think it was 86. It was conceived. That's coming on for half a century ago. I think people think, oh, old, it's not very relevant anymore. But actually, it was designed by Bosch almost perfectly for automotive. It's really well designed, and people that want to move away from it, I think, need to really understand why they want to move away, and be much more conscious of what it's trying to solve.
Yeah. So I think some of the questions I would, a couple of points that, pick up on what you say there, like, is investigators of, say, serious collisions, where we're looking at vehicle speeds that might have been stored on a vehicle. It's interesting there that you say that the speeds from those four wheels could be broadcast, 1,000 times per second. Is that realistic?
Yeah, every 10 milliseconds.
Yeah.
That's quite common.
Yeah, when we see pre-crash data, we only, in most cases, see records every half second.
Yeah.
So if we're looking at the way that the vehicle's been behaving in the lead up to the crash before the actual deployment of the safety restraint systems, then we're only seeing a small amount compared to what's actually being broadcast on the network at that time.
Yeah.
But when you've got 10 records in those 5 seconds and they are pretty consistent, then there's an argument that that data set doesn't need to be as accurate as what other vehicle systems need, for the reason that it's being broadcast so many times per second, 10 milliseconds.
Yes, that's right. So this is quite like an aircraft control system and a black box flight recorder. So what they're saving is some essential data at a reasonable rate. Because one of the problems is, if you're going to capture and store all of that information, that's an awful lot of information. And if you want to store that in non-volatile memory, the time taken, so it'll be stored in a little buffer in memory in a loop. That memory is going to be quite large if you're storing a lot. And one thing the car industry doesn't like doing is spending money. And the more memory you require to store it, the more money. And even if it's only like 20 cents per car, when you're making millions of cars, it starts to add up to a lot of money. And the whole account is designed not to spend money. So that's why they do this. So there'll be a small buffer, and then it's written into E² memory or flash memory or something like that. Stored in the microcontroller. But I don't know, things are moving on, and I think the cost of memory and things is different now, and I think the manufacturers could take another look at that. Obviously they're not doing it for crash investigators per se. They're doing it to find evidence of why they're not at fault. Primary motivation in the early days was unintended acceleration events and so on. You want to kind of show that they're not happening.
And I think that that's my personal opinion, is a lot of some crash data is being made available now because of the period of time we're in between this transition of drivers in control to vehicles being in control. And I think there's maybe a little bit from the manufacturers wanting to safeguard their technologies and to show what, to be open about it, but to show what has been going on in there. And I think you're right in the sense that storage capacity across all our digital devices is just increasing and perhaps becoming cheaper. When we look at the size of memories on smartphones, etc., those technologies are significantly increasing to where they were. But I also take your point about the automotive industry trying to keep costs down, and sometimes in the past, I've been guilty of perhaps thinking that crash data was stored on an airbag control module, and that manufacturers did have that, but they just didn't want us to have access to it. But equally, I can see an argument whereby if you're going to put an airbag control module in a vehicle that is going to deploy the safety restraint systems on the vehicle and protect its occupants, but not store any data because it's going to cost you an extra 20 cents to have that facility on there, that if there's no legislation, and there hasn't been in Europe, why would they, for that market, use that component when there's no requirement for it and they get what they need from the cheaper component that goes into the vehicle?
Yes, exactly. So, and everyone's doing it for their own reasons. Some might be putting it for more kind of altruistic reasons, but altruism is a weak way of doing their engineering. And also, some of this reflects past thinking. When I first started with the Volvo project, one kilobyte of RAM on a microcontroller was a lot of memory. It was all of it. And this was controlling door opening and the Windows controls, and you've got 1 kilobyte of RAM. So you can't buffer more than a handful of bytes
Yeah.
that you want to then store. So and so that's a mentality that kind of gets embedded in a design culture, and you know, it's very important to stick to that. You know, when you see PCs with 32 gigabytes of RAM and stuff, you know, the difference in the world between computing and automotive engineering is huge.
Yeah.
But I think today you're seeing, you know, devices with hundreds of kilobytes of RAM now. So I think you know, if someone re-looked at the issue and put it into focus, I think you'd see a different answer now.
Yeah.
But it depends, you know, what the motivations are all the time.
Yeah, absolutely. So sticking with vehicle speed as a message that's broadcast on the CAN network, is that something? Is that data type one of the, shall we say, more frequent messages that's broadcast, or is there something that's broadcast a lot more frequent than that?
No, so normally 10 milliseconds is about the fastest frequency for broadcasting data. So that will be all the stuff where you want to start doing control, like traction control, where you want different brakes and gearbox and engine and stuff to all talk to each other and see what each other's doing. So it tends not to get any faster than that.
Right.
CAN's not massively fast. So in powertrain side, it'll be running at about 500 kilobits normally. And in the body electronics side, 250 or maybe even slower than that. So if you start to look at the data, so on the powertrain side, sending 8 bytes of data takes about 260 microseconds. So that's 4,000 a second.
Yeah.
Which is not very many. So if you're going to take 100 per second for wheel speed data, you know, there's only a certain budget you've got before you run out of bus capacity.
Yeah.
Yeah, that'll be the fastest rate, 10 milliseconds normally.
Yeah. And it's down to the individual manufacturers to decide where they allocate that sort of space for their technologies with regards to those messages that are being sent and in what sort of format they do, depending on where they're at in the development of the products, I guess.
Yeah, so CANBus for car manufacturers is a proprietary bus as far as they're concerned. They have complete control over all the messaging. They define how often the messages go. They define what format they're in. They define what units and scales the signal values are. It's completely proprietary. They'll carry it over from one car project to another to reuse components, but it's entirely. So yes, if you get a BMW and a Ford, and look at the messaging, they can be completely different. Diagnostics messages are trying to keep that kind of standardized. So if you send diagnostic messages back and forth, then they are in a sort of an industry format. And if you look at trucks, because of the way the truck industry is structured, they aren't proprietary. There's the SAE publishes I think twice a year a very large book of all of the messages in CAN and all their identifiers and all of the formats of all the signals that go in them. And the idea there is you can, because of the way trucks are sold, the fleet operators often pick their own gearboxes and powertrain, engine management gearbox, and so on, and they'll pick all kinds of different components, and they all want to be able to plug and play with each other. So everyone sticks to what's defined in the book. And the reason they publish it twice a year is, of course, innovation means you get new things come along and they have to have new messages with new contents and new format because it didn't exist 30 years ago. So they have to keep it up to date, which is a constant headache for everybody.
Interesting. I just want to go back to when you talked about diagnostics, because certainly myself and some of the people listening to this podcast will experience obtaining speeds of vehicles from diagnostic logs in what we would term as freeze frame data. And I guess we've seen some research papers that kind of tend to validate that those speeds are quite accurate with regards to what the vehicle was doing with some independent testing equipment. But from your perspective, could you give us an insight as to maybe how the network is working when it's recording those speeds along with those faults with regards to time?
Yeah, so what will happen is again, the freeze frame would typically, each electronic control unit would typically have its own freeze frame, but the data it's freezing didn't come from its own unit a lot of the time. Some of the data, so the speed, vehicle speed and so on, it keeps its own copy of that, and that's come off the CANBus. And it would be unusual, I think, to rewrite or change those values. They'll just be freezing whatever the latest speed value was off the CANBus, putting into that little local buffer that you then squish into the non-volatile memory. So those numbers very likely have come from CAN. They might deformat conversions if they want to reuse old tools, and things have changed on the CANBus and stuff. But that's the source of a lot of this data will be straight off the CANBus. And the speed values are very accurate. I mean, when you're doing tire, I don't think they do it much nowadays, but tire pressure calculations were done with those 4-wheel speeds. So if you constantly see one wheel is rotating at a different speed to the other 3, it's a soft tire, and that's how you used to flag that up. Without even the RFID tire pressure warning system. So that information is coming off the CANBus.
No, it's reassuring to to hear that. But I think the learning point already for me out of that is, we only sometimes, if we're lucky, we get a timestamp associated with when the fault was created, which again, from my perspective and my understanding, that would be coming potentially from the vehicle time, with regards to what was being displayed, maybe, or what time the clock was set to.
That's a really good question.
There are we have to, when we're dealing with freeze frame data, we have to look at some plausibilities around, did those faults occur at the time of the crash? So what is the fault, and does it marry up with the circumstances of the collision? If you do have some dates and times associated with it, I mean, we work a lot with the VAG group, and using VCDS, that does contain a lot of dates and times associated with with those faults. And our understanding will be that time is taken from what the instrument cluster would be showing. So sometimes we can't always do it with a crashed vehicle, but we would look to if we can get power to the vehicle and see what the date and time is set, or whether or not there is an offset to the true date and time as it is now, and whether or not it's set manually. It's not so much of a problem sometimes with a crash where the vehicle's not moved since, and those faults, it's littered with faults that are all applicable to the crash. But sometimes when they're not like that, if say a vehicle's failed to stop with send it up with a broken circuit somewhere that's logged a fault with a speed associated with it, when we're going to go to recover that vehicle, which could be some weeks later, then those are the sorts of things that we need to try and take account of. But I guess if you could give us an insight that perhaps different manufacturers will have different ways of associating dates and times with faults, etc.
Yeah, so I remember talking a long time ago with Rover about this, where you pull the time from, because systems with GPS have got access to GPS time, which is basically atomic clocks in orbit. So they are accurate, super accurate. But some pull them off of RDS, off the radio. Some will have little battery-backed real-time clock things there, or in fact, they won't even be battery-backed. They'll be on a little capacitor that's charged up from the car battery. So there may be several sources of time, date and time, in the vehicle, and which one any individual ECU uses could vary. The ECU might have its own. It might be measuring its time from key turn to then when it gets something off the CANBus to say what the time is. Some in the early days, they didn't record any kind of date related stuff on the CANBus.
No.
Partly because you don't want any date related bugs causing ECUs to crash, because then suddenly all around the world, every model of car would all cease to work at the same time. It's a horrifying prospect.
Right.
It's really interesting. I suspect you're going to find that it's like CCTV with the clocks all over the place. And in fact, you might get better results by trying to correlate common sensor values. So like the speed will be accurate, and it might be stored and pulled off the CANBus for the latest speed. And by correlating all the speed values together to see where a particular pattern arises, that's how you can then cross-correct all the timestamps. Because I suspect the timestamps are the least reliable data that's been put into free. systems.
And I am sticking with speed here because it is something that we deal with a lot. If we have to take care of certain vulnerabilities with what's been going on with the vehicle at the time of the crash or in the lead up, but some modern vehicles, will be my understanding that if you've got a wheel that's maybe say on a grass verge that's spinning a lot faster than the rest of the wheels, that will get taken care of or offset before it's broadcast onto the CANBus network, present of it being an implausible signal when it's looking at the other three.
Yeah. So normally what will happen is there will be quite a few vehicle speed sources. So the 4-wheel speeds is one, and then so one of the ABS systems I work with, they put out 4-wheel speeds in one CAN frame, and then they put out a normalized speed value on the bus that was to be used by more kind of instrument cluster and so on, which doesn't need the 4-wheel speeds, and that will go at a much slower rate. Kind of coming back to the timestamp thing, is you could find that different ECUs have picked up and used different qualified speed values that have gone through different levels of kind of processing. So the ABS would have typically removed outliers and then done some averaging of the wheels, and that's averaged maybe either a snapshot or averaged over 100 milliseconds of time, and then put out. So that is another problem, is who is taking the wheels or the speed of the vehicle. You can some systems like the gearbox will know how fast the engine's going and what gear you're in, and that will give you the speed as well. So different systems will have different sources for their speed values, and if you could get access to all of the really good data, when there's discrepancies, you can start to find out, well, that wheel was spinning and therefore this was probably off the ground, and this was and the gearbox is probably in some way broken or detached, or the rear wheels are spinning, and you have lots and lots of information, but that's not what they're recording in the freeze frame. So
no,
which is a bit sad. What would be really lovely if there was some kind of black box recording the CANBus, and you got access to all of that in a freeze frame, so you could do complete deep dive forensics onto all of the CANBus, all of the ECUs over half a second or something, and that would be a much deeper picture of what was happening to the vehicles mechanically.
That's really interesting from my from my point of view, and I'm sure some of the listeners will also appreciate that the complexities of what's going on with a modern motor vehicle underneath what you're seeing in those speeds, whether they're presented to you from an airbag control module or from freeze frame data, is much more complex to what you're seeing superficially. And I think finally, to wrap this section off for me, is sometimes you've got a bias added to a speed as well on the network, so that the vehicle is not reporting that it's traveling. Can I forget which way around this is, but it can't be showing that it's traveling any slower than it actually is, or any faster than it actually is, for some tolerances that are applied on speedometers. So if a GPS speedometer, you'll often find that that's reading slightly less than your car speedometer. And I think sometimes that's an area that people either neglect to take account of, and it can be different across different manufacturers as to where that either speed bias is added, whether it's added straight away before broadcast, whether it's added in the instrument cluster itself, and what you see in the airbag control module is actually the true speed. I've certainly experienced that there's sort of a variety of different ways in which manufacturers can add that speed bias into a speed that's seen on the network.
No, I've seen that, because I think at least in the UK the law is -0 +10 for accuracy, and of course when you're dealing with things like ABS, your accuracy is much better than any of that. But the car itself wants to work on real values and not fake ones, because distance traveled and all the tire pressure calculation stuff, you want real values, you don't want to be messing with that. So on the bus, we'll be going normally accurate values. There may be, and then there's a filtered value for the driver to see on the instrument cluster. That might come from some other device, of course. So it might be doing the speed and then sending out this is what I mean by there being many speed signals. So there might be a speed for the instrument cluster to use speed. But the freeze frame on the ABS, on the airbag really should be using the proper speed. Because it's doing those calculations and for the accelerometers being updated. So if you used your fake speed for that, I think that would be, I mean, it might happen by accident, but I wouldn't think there's a risk.
I've seen it with one manufacturer where the speeds from the airbag control module, they've said that the bias value has been added to that from the body control module.
Yeah, so that's probably, well, so this will vary, and this must be another source of incredible frustration of everything is different, and then between models of car and even model years of car. Yes, I mean, this is crying out for an area that needs to be properly standardized.
Standardized. Okay, so I've talked about some of the vulnerabilities of say accepting speed data on face value and what have you. From your experience in working with CAN, what other vulnerabilities should we be aware of with regards to the communication process that's going on there? People are meddling with their cars, or damage that's potentially not immediately visible if you're not maybe doing a full diagnostic scan on a vehicle that's maybe got some minor damage. Are there any vulnerabilities? And I know you've explained how it's quite a robust system, because for the message to get delivered, then everybody's got to acknowledge it, kind of thing. But are there any other sort of known vulnerabilities? And I'm probably scratching under the surface a little bit here as to those messages that are broadcast on there. Because I'm kind of linking this into data that we might see that's being broadcast on the CANBus that's stored on an infotainment head unit with regards to its accuracy.
So CAN's very robust against kind of random noise and so on, but hackers are effectively choosing the random noise if they want, and therefore it's not random and it's not robust if it's being deliberately engineered to break into the system. So once the CANBus has got fake stuff on it, then you could be looking at effectively tampering with the forensics, and maybe that wasn't the intention, but what gets stored, if it's coming off CAN, will be fake. So you have to be aware of that. And in terms of what's probably out on the streets now that will be messed around with, it will be two things. One is CANBus theft systems. So if you talk to Ian Tayboy, he had his car stolen via CANBus. A couple of his neighbors, I think. So those systems there, they've got little boxes that you can scroll down and choose which model of car you're about to steal, and you press a button and it deactivates the immobilizer and locks and everything. And you get onto the CANBus by finding some place where a CANBus is visible. So headlight cluster, even just punching holes in bodywork, you can find access to the bus.
I'm not sure I understand.
And then you broadcast on the CANBus fake messages as if it's come from the engine immobilizer or something like that. And of course that'll end up in the freeze frames. And very often they're not very careful about the way that they send this stuff, so they will cause lots and lots of diagnostic trouble codes and freeze frames to be dropped. And what those freeze frames then contain, who knows? So if you're, for example, if you're spoofing, say you're spoofing door locking commands or door status updates, they may be the real one, and then there's a spoof one, and they may come very close together. And if the spoof one came just after the real one, and then it would overwrite the real one, and so whatever was doing the freeze frame would drop the spoof value. Or if the real value came just after the spoof value, it might drop the real one instead. So someone's been doing CANBus hacking to steal the vehicle, and then it's recovered. Your forensics could be anything at that point, I think. It's really tampered with. So then you've got to start putting a picture together of what might have happened. The other issue is people are plugging devices into their OBD2 ports. So insurance companies sticking their dongles in there, and the security of these dongles when they're connected to GSM and stuff is not as good as it should be, let's say.
Yeah.
So it's possible that some of the hacks came from the internet through some servers and then down into the car itself via the dongles, or the car was moving and someone hacked the car while it was moving and maybe deliberately caused it to crash.
Yeah.
I don't know if we've seen any of those, but I don't know if we would see any of those yet. If it's common, unless it's common, you probably wouldn't have seen it. And if you did see it, with the limited data that's being captured, you would not know that it came from that.
No.
And then you've got owners of their vehicles who have added hacking things either through the OBD2 port, or they've attached something permanently that in some way defeats some kind of device on the car that they don't want operating.
Yeah.
So we've seen this for truck operators who don't want to pay for AdBlue. They just basically put a little hacking box in the way that fakes the AdBlue sensor to say, yeah, I'm using it, and the emissions are all wrong, but they're not being recorded properly. So I think those are the things to look out for is vehicle modifications. So has it been stolen and hacked? Has the owner put something in and changed it by adding fuel? And what was in the OBD2 port after the vehicle's recovered? Anyone take that out?
No, you make some really valid points, and to complement those, I think one that we see fairly regular, I guess, or regular than, or I don't say regular, they are prevalent, mileage blockers for people that are on, a contract whereby they've got a limited number of miles they can do on that, and they're either trying to reduce that because as soon as they go over, they're going to be charged and financially penalised, or for people that want to try and keep the value of the car. The second-hand car market at the minute is quite buoyant here in the UK, and things aren't cheap, and people will try to maximize the financial side of things, especially after a pandemic, and a lot of fraud can go on in that area. So I've certainly experienced that on 2 or 3 occasions of mileage blockers in there, and I guess that's an example of the CANBus being interfered with messages not being received by
that's an interesting one. I guess that's probably what they're doing is on the instrument cluster, the same as the AdBlue. You would cut the CANBus and put a little dongle between the two, so the instrument cluster thinks it's on the main CANBus, but it's not. It's on a little private one, and then the messages have been rewritten on through just to lie about the mileage. Odometers might not be stored in instrument cluster. There might be the primary odometer might be somewhere else in the vehicle now. It just sent from the cluster display it. So these are all
they're all these are sorts of things that owners will we did a Friday feature on mileage blockers the other week, and there's plenty of websites advertising them for sale now for your brand of vehicle, and can be installed by you with the support of a phone call to them that to them that are providing them. I think about the stolen vehicles, and that is an area that does really interest me with regards to what can be learned from vehicles that are recovered, potentially whereby that equipment has been used, or getting a hold of that equipment that is being used to understand a little bit more about how criminality are doing this side of things. We often sometimes call criminals dumb, but they're not dumb in this regard of the way that they're probably very crudely, but are overcoming some of these systems and putting an exploit on a manufacturer that causes them a massive headache to try and resolve. And sometimes the issue is you're developing a vehicle architecture years before it comes to market, and to buy the equipment to compromise that at the time of development is going to be a cost that you would never expect somebody to be able to meet. And then as time moves on, technologies become cheaper, and the exploit can be done a lot more crudely and without having to spend a lot of money in the fullness of time. But I think it's an interesting point you make that and for me, it goes back to knowing that vehicle's history. Has it ever been stolen before, and how was it stolen, to what might be not quite right on the CAN network if you're investigating it as part of your current investigation, if it's had some messing about done with it before.
That's a really good point. yeah, someone might have put a little dongle in there,
Yeah.
and yeah.
And I think, how do you then, would there be evidence on the vehicle networks or on some of the ECUs as to of that device interacting with the vehicle and stored anywhere, or would there be, it's just lifetime sort of stuff that's not stored anywhere to be able to help us detect who was behind that attack?
Right. So if you've obviously got the vehicle, I mean, depending where they put it, you probably don't have the resources to go through all the wiring loom and look for things on it. But you could detect timing behavior changes versus a stock model. So, for example, the instrument cluster that's been sort of partitioned off onto its own little network, there'll be difference in timings because it's got to send it on the CANBus and then again, and then the other messages go through and again. So you can see the difference in timing from the instrument cluster's responses well out of line of what a normal vehicle would be. So you could probably detect iffy things on there. And there's certain very low level electrical properties of the CANBus that you can see if the bus has been cut and changed because of the way the CANBus is terminated, and that affects certain impedance properties of the CANBus and stuff. You could probably detect tampering on that, and yeah, you could probably build a little tool that would come up with, this is an iffy CANBus or this is not an iffy. What you couldn't do is obviously go back in time for data that was never recorded, so you couldn't say who did that.
No.
And again, I think this is where you could go back to this concept of a standardized black box. If it was recording all of the information, and it was a standardized thing that every car had to have fitted, then you could actually start to it could record around anomalies, interesting things. It could drop information so accurate and precise it could tell when the CANBus was cut, and so on. So I think you could resolve all of these things, but again, you have to. You're on the end of the chain, and you need to be right up at the top of the chain of development to get it changed. And yeah, that's very hard.
Yeah, I would acknowledge that it would be very hard, considering where we've been and where we're probably currently at with things.
I mean, the insurance company dongles thing, it might be a place to try on that one, because an insurance company would like to know whether their dongle caused a crash because the hackers hacked it, or did the owner tamper with the vehicle and cause the crash. So you might find that there was some push towards those insurance company dongles having some kind of flight recorder capability, which could be done.
My experience with insurance companies are, if they don't have to spend any money, then they won't. They're probably worse than the manufacturers with regards to parking. Anybody in the insurance sector listening and wish to contradict that, please get in touch.
Yeah, quite.
Okay, I don't want to spend a lot of time on other networks, but I think it's just important to mention some of the other networks on the vehicle, because CAN is just one, and there are many others working in tandem with it or across modern vehicle. But one of those, I guess, would be CAN-FD. Can you just explain what CAN-FD is?
Okay, so when people say CAN, sometimes they mean CAN-FD, and so CAN-FD came around because it's CAN was old, and it's lots of functions been put on it, and eventually the number of functions put on it kind of exceeded its capability for bandwidth. So CAN-FD came along a few years ago to try and find a way of speeding up CAN. So some systems have CAN-FD running at because of the way CAN-FD works, it doesn't run as fast as everyone hoped it would run at because of the way these electrical things on the bus work. So they tend to run them at about 2 megabits. So it's like a version of CAN. But it's not backward compatible with CAN. So old CAN hardware won't work on a CAN-FD network necessarily. So you're probably starting to see CAN-FD coming around. It's because of this compatibility problems, it's not rolled out as fast as everyone thought it would. So
right. Okay.
Now there's a new one coming, which is called CAN-XL. That's just right now getting its first silicon availability. It's just starting to come out, so you would see that on vehicles in 5 years probably.
Yeah.
Hitting the road maybe a little bit sooner. And that runs at 10 megabits, but it's electrically a completely different electrical thing down at the cabling level. So you won't find old CAN stuff on that. It'll all be new CAN stuff. So there are kind of 3 CANs. There's the classic CAN that we've been talking about. There's CAN FD, which is kind of an attempt at a speed bump, and then CAN XL, which really gives you the speed bump.
Yeah. So do you ever see a time of CAN not existing then?
Yeah, this is a good question. I mean, the industry is asking this itself, because there's lots of this move towards let's use Ethernet in cars, and there's a couple of sort of automotive Ethernet standards around, one that does 100 megabits and one that does 10. And Ethernet is not a thing designed for automotive. So personally, I think it's missing things like the atomic broadcast that I talked about guaranteeing all the frames arrive to everyone. So I think but you need something like Ethernet for cameras for doing driver assistant and stuff like that.
Yeah.
So I think you'll see a hierarchy. So there'll be Ethernet used around the backbone, and then various local CAN buses in the region where those sensors and actuators need to be. I don't think that's going to go away, because it's cheap, robust, highly effective. It works. So I think you'll see CAN and Ethernet together, but I don't think CAN is going to go for a long time.
No. Which brings me on to, how do we secure the CAN network then?
Yeah, so
very briefly, and give us the headlines on this one if you can.
Yeah. Okay, so there's a bunch of different techniques, and they all have different properties, and they can all be overturned in different ways. But if you use them together, it becomes very hard for an attacker. So one of them is to use encryption on the CANBus. So you encrypt all the messages. Hackers can't see what those messages contain. So in the very first time, they can't reverse engineer it, and then they can't spoof messages. So the guys on the street that are breaking in and spoofing the immobilizer can't do that anymore. There might be some very long-term uber hacker ways of breaking that, but I don't think that's any kind of short-term risk. The second way that's quite common now is like firewall gateways between areas where the biggest risk are, and infotainment is the biggest risk, because that's just a poorly maintained, poorly updated computer system in your car. And so nearly all of the high-profile trophy hacks have been on the infotainment system. So you can hack that through Wi-Fi, Bluetooth, the internet, all sorts of things, and you keep it off the main CAN bus with a gateway or firewall. So that's a common one, and you firewall off the OBD2 connector, because you don't want your hacked dongle to be accessing the CAN bus. So lots of people now plugging OBD2 dongles in, thinking they can mess around with their car, are in for a shock, because there's now gateways being put in place. So all you get to see is the classic diagnostics and nothing else.
Which is always a rub for the right to repair people
for
their vehicles. And
you see this all the time.
Isn't it? Convenience or consumer rights versus security.
Well, I was just reading one about Apple laptops with the M1 silicon. They've got special security hardware. If you don't go through the process when you decommission your MacBook, no one buying it. So if you buy a MacBook at auction, or you buy it from a company, if it hasn't been properly decommissioned, it cannot be used by anybody else. It's scrap. And that's to make sure that thieves can't steal your MacBook. But if you decommission it, you can sell it.
Right.
Which of course is so people are saying, well, why buy 1,000 MacBooks from a bankrupt company and they're all scrap? It's like, but if a thief came in and stole 1,000 MacBooks, you'd be very upset if they could repurpose them. So it's a conflict, and there's no way around that. Is that there is always going to be some kind of conflict between security and right to repair.
I mean, we do see at the moment, and certainly some of the work we're doing, we're limited now with some of the diagnostics equipment on some of the modern vehicles as to where we can go to get information that we might previously, on 2 or 3 years ago, been able to see and get. You can see that they are, closing those areas down for people either like ourselves or enthusiasts that want to experiment with various things.
Yeah, I mean, there's no generally you shouldn't be driving an experimental vehicle on the road. I've seen
No.
people using old Android phones with their cameras to steer their car, and it's like you really shouldn't be doing that. That's just not on. Other people's lives are at risk. So I can see the lockdown perspective, but the other side is like, I don't want to, it's an old car. I don't want to go through the dealer network. I want to maintain it myself.
Yeah.
It's a completely valid position also. So
yeah,
again, I think this will have to come down to regulation in some way of defining where that fairness line is and the essential line is, because right now car manufacturers are required to lock their cars down from being hacked, and they are required to give third-party access for maintenance.
Yeah,
they've got to square a circle there, and it's difficult.
It is, and we've had conversations, with the manufacturers from a law enforcement perspective. Well, we might want some data for law enforcement investigation reasons, but it's like, well, you're asking me to lock it down on one side to make everything, as soon as I create a back door, then there's a vulnerability, with the system. So you can't have it both ways, really. And I guess safety is always going to take primacy over either right to repair or investigators wanting vehicle data off a vehicle.
Yeah. No, I think there just has to be defined proper channels and defined lines for this. Around.
And the other difficult part for us really is because it's a global entity, and the automotive industry is global with different things in different regions across the globe. It does make it a little bit more difficult for people to get those frameworks in place for their regions, I guess, because of the politics that go on between, the global departments of the automotive industry when they're dotted around the globe.
Yeah, no, that's right. So the EU can write regulations, but that's that's a big factor. I mean, in the US, California used to basically set all the emissions regulations because it was such a big market and everyone had to just toe the line. But it's fragmenting as well now, and and everyone, manufacturers want a global product, so some harmonized regulations would be really useful, but that's difficult.
We'll see. Okay, we're going to finish off by asking a series of questions that we ask all our guests that I hope you might have had a chance to have a little think about, but we'll rattle through these to conclude. What do you wish you knew before you started in your industry? Your hindsight could be the listener's foresight.
Yeah, well, the thing about automotive that I wish everyone has to learn it, but it takes time to really internalize that $1 is a lot of money, and the reason that these things exist in a certain way is to save small amounts of money multiple times across very large volumes. And when you come in from the outside initially and you don't appreciate that, everything just looks stupid and it looks like the whole industry is full of idiots. It's like, no, they've been around for a long time. They know how to make things. The automotive industry runs on tight margins. It's a safety critical product in high volume. It's exceedingly difficult industry, and they're not full of stupid people. It's for good reasons, and it would save a lot of time if everyone coming to the industry could understand that. That's why things are the way they are.
No, that's a very good point, and one that I have also started to learn, as I touched upon beforehand, with why sometimes data might not be recorded. Can you give us an example when you failed recently, and how did you overcome it? I'm a massive advocate of failing because it's the only way we learn, and I think it's good for people to see that we do fail, and we need to fail to move forward.
Yeah. So one of the things I'm primarily working on is I mostly do chip design now, and we've designed a way of backwardsly compatible with CAN, getting its speeds up to 10 megabits. With like secret data in the gaps between CAN bits. It's too complicated to talk about, but and everything worked on all of the test rigs we put together. And then when it went out to a customer's test rig, it failed because the quality of the wiring was very different, and the noise and the electrical noise on the bus was very different, and it's. We had to go right back to the drawing board and completely rethink the way the data is encoded to try and work around these problems, because I I don't know how representative their wiring is going to be, but I think it's better to try and fit as much wiring, poor quality wiring as possible, and then kind of have a way of ramping up when it's better. So that would have saved a lot of time if I'd have found that out earlier.
How do you think you could have found that out earlier? Because I'm going to sort of divert a little bit here. I'm guilty of this as well, and I think sometimes we hold back on putting something in, say, customers or people's hands as to what we think is right. And would it be better to have had an earlier version of that go out, or is there a way around you could have accelerated that?
Actually, what we in the end built was an instrumentation system, a test instrument that basically fires it's kind of like a spectrum analyzer, but in a different ways, aimed at that CAN. So we actually were able to test the whole quality of the wiring. It kind of goes back to what I was talking about before about the forensics could use the same technology. If you can work out where there are cuts on the CANBus and things like that. So if we'd have built that tool could have been run on that rig a lot earlier.
Did that tool come out as a result of that?
Yes. So perhaps not.
But there is a positive to take, from that. And often this is what I mean. You kind of think that it's a fail, it's a fail, but as a result of that failure, look what you've managed to develop as a result of that. And it's not a fail, is it? It's just a learning cycle that has allowed you to develop, something else that will improve things in the future, I guess. So that's a really good example, I think. But I think human nature makes us feel deflated, especially when we've spent a lot of time doing something, a lot of time, a lot of sweat and tears, and you get to that point. But I guess that's why there's, a lot of people having to readjust their thinking about failing, and this is why I want to try and get these examples out into the wild a little bit, because I think human nature is to think that we have to get everything perfect first time, and the reality is that we don't do that. And I guess that overlaps a little bit into the automotive sector when I say new technologies go on the vehicle and the manufacturers will not want to accept that their product is faulty or liable for obvious reasons. But maybe they do to learn a lot quicker and to acknowledge, some of those things around, around failing, that certain systems aren't working as they should do. Yeah. But no, that's a really good example. Thank you for that one. Can you point our listeners to a recommended resource that you would go to around CAN? Or
that's a good one. It's very, very fragmented, the whole CAN space. It's very hard to search on Google because the search terms just bring up tons and tons of just mishits and stuff. So yeah, I find that very hard. I tend to use LinkedIn when there's an awful lot of people with a lot of knowledge on this, and if you follow the right people, stuff bubbles up. You can kind of focus down. I mean, it's a classic one, isn't it? You find the right people and then they know people and so on. And in the end, I mean, it really shouldn't be that way. It should be a nice, simple resource that you can plug into, but that's not the way it is at the moment.
No.
I think. I mean, what you're trying to do with the apps seems to be the right way to go, and collect it all together.
Yeah, I think, many people in the automotive industry, and there's that many different sectors in it. The common thread, whether I'm dealing with vehicle forensics, cybersecurity, repair industry, the common thread is that we won't solve it alone, and you've got to work collaboratively with other people in order to resolve the issues. And if you don't, you're just going to struggle with it. And yeah, that is one of the reasons why we've got the app up and running, to try and bring those people together to resolve some of the issues that people have, and we can accelerate resolving those issues a lot quicker.
Yeah.
Are there any myths about your industry that you'd wish to debug?
Oh, yes. A car is a phone on wheels. God, I wish I could kill that one.
Yeah.
that myth. It's so depressing that because people see infotainment as the thing in front of them, therefore this is the computer in the car, and it looks like a mobile phone, and it's got Apple AirPlay or Android Auto and stuff, and therefore this is the thing that controls the car. It's nothing like that. And even if it were true, that there was a central computer like that. A car is not a phone. It doesn't kill you if it loses control. A car is a safety critical system. The way you engineer safety critical systems and the way you engineer consumer electronics are completely different. They have completely different volumes, cost points. No one is expected to maintain a phone for 30 years. It's such an unhelpful myth. So yeah, and
it's a good one. I have heard that being explained in the courtroom by other witnesses around vehicles and vehicle technology, that it is a mobile phone on wheels. And unfortunately, in court, you can't just stand up from a spectator's point of view and debug that myth there and then. But it's great that you bring it up, because I would agree with the points you make. But I often hear that being said around some of the circles that I operate in as well. If you were in my shoes, what question would you have asked yourself that I didn't?
Probably. What's the prospect for worst case scenarios of or car hacking?
Okay.
What could go wrong if you let your paranoia run loose? And in a security perspective, paranoia is like, how much is paranoia and how much is genuine risk assessment. So one of the things that could go wrong with cars when they're connected, I kind of talked about this, about the date clock and all the cars crashing at the same time. If someone tried to engineer a whole fleet of cars to crash at the same time, that's perfectly technically viable. There's no science fiction. There's no. It's just a question of effort to uncover the bugs. Infotainment is riddled with bugs always, and if you can break through the security gateways, and we've seen security gateways with bugs that people have broken through into on tests, then somebody could, well-funded researchers, nation-state hackers, could disable every single model of car around the world at the same time. And if you imagine what 500,000 cars all coming to a halt on the motorway network could do, that would shut down the power system, because people couldn't get shift work. Shuts down the airspace because you can't get air traffic controllers to change shifts. The whole transport system comes to a halt, and it's like someone mounted a major attack on your country with weapons. So I think there's I don't know if it's paranoia or not, but I'm looking at it thinking it's possible.
I think we have to. And when you kind of make that statement, and it comes from somebody with the authority that I feel that you've got within the industry and your experience, people need to listen, because it's often the case that, well, I told you so, but it seems so far-fetched or so unlikely, or Fast and Furious 9 or 8, whatever it was, when that kind of thing happened. Often we see things that do become a reality in the fullness of time, and science fiction is more probably better described by most, I think, as science fact, or those that look into it, because there are probably not many science fiction films that have not become a reality at some point down the line. And it's a valid point you make, and there's maybe a reason why I never asked that question, and not to scare the audience. But thank you.
I don't know what the risk is. I just don't know if I'm being paranoid or
and highlighting it. Okay, we are putting a playlist together on Spotify for guests of this podcast as to what track they would sort of go to for driving on a long journey. If some of our subscribers are on Spotify and they want to listen to the eclectic playlist that's been generated, what would be your go-to track?
My favourite one is Lifted by the Lighthouse Family. I think that's a 90s thing. They might have used it in an advert for cars. That's maybe made me think of it as a driving song. But it's a one that it feels like it's sunny and the rain has stopped kind of song. It's particularly good if it's a terrible weather outside the car.
It is an uplifting song.
Yeah.
And where can people find you online? I will put a link to your website under this podcast in any event. But are you? I know you're active on the socials a little bit. Where can people find you?
Yeah, so I'm on LinkedIn, and I was on Twitter, but I've moved to Mastodon. Lots of people.
There's a lot of people doing that. I think.
So so Mastodon's is where I'm socially active most. Yeah.
Right. Okay, well, thank you for joining us. I'm sure the listeners will have found this really useful. And if they've got any questions that they want to direct to Ken, then by all means come back to myself or search him out on some of the socials. And I'm sure he'll be more than happy to speak with you. Thanks again for joining us. And we'll look forward to presenting you another guest forthcoming on the Vehicle Network podcast in due course.